Hello everyone, welcome back. In this tutorial, we'll learn how to manage AWS Lambda functions using AWS SAM, the Serverless Application Model. AWS SAM is an open-source framework that helps us build, test, and deploy serverless applications easily. It simplifies CloudFormation and is perfect for managing Lambda-based, event-driven applications. Why AWS SAM? Without SAM, Lambda deployments involve long CloudFormation templates, manual updates, and difficult testing. AWS SAM makes this easier by providing short YAML templates, built-in best practices, faster development and deployment, easier debugging and testing. Now let's look at the core components of AWS SAM. First, we have the SAM template, usually called template.yaml. This is the heart of the application. It defines Lambda functions, API gateway, IAM permissions, DynamoDB tables, and event triggers. Next is the SAM CLI. This command line tool allows us to create projects, test Lambda locally, build the application, and deploy it. Finally, we have AWS CloudFormation. Behind the scenes, SAM converts our template into a CloudFormation stack and deploys it automatically. Now let's install the AWS SAM CLI using a direct download method. First, open your browser and go to the official AWS SAM CLI documentation. Scroll down to the installation section and select Windows. Under Windows, click on the 64-bit MSI installer to download the AWS SAM CLI. Once the download is complete, open the MSI file. The setup wizard will open. Click Next, accept the license agreement, and continue with the default settings. Then click Install to start the installation. After the installation finishes, click Finish to close the installer. Now open Command Prompt or PowerShell. Run the command SAM version. If the version is displayed, the AWS SAM CLI has been installed successfully. Now let's understand the architecture of our project. Here's how the flow works. A file is uploaded to the source S3 bucket. This upload triggers a Lambda function. The Lambda function copies the file to a destination S3 bucket. Then it sends a notification using Amazon SNS. SNS delivers an email notification to the subscribed email address. All these resources will be created using SAM deploy without manually creating them in the AWS console. Now let's move to the SAM template and app.py file. In template.yaml, we define the Lambda function, source and destination S3 buckets, SNS topic, required IAM permissions, and the email parameter for SNS subscription. This single template replaces a long and complex CloudFormation file. Inside src/app.py, we write the logic to read the S3 upload event, copy the file to the destination bucket, and publish an SNS notification once the copy is successful. Before deploying, let's verify which AWS account we're using by running. This confirms the AWS account and IAM identity, helping avoid deployments to the wrong account. Once verified, we proceed with the SAM deployment. We run the build command. This command prepares and packages the Lambda function. Next, we deploy using guided mode. During deployment, provide the following details. Stack name as S3 copy and notification. Choose your AWS region. Enter your email for SNS notifications. And allow SAM to create IAM roles by typing Y. Important step here. You will receive an email from SNS. Make sure to confirm the subscription, otherwise you won't receive notifications. Now let's move to testing the application. First, confirm that the CloudFormation stack is created successfully. You can check this in the CloudFormation console and make sure the stack status is create complete. Once the stack is ready, Upload a file to the source S3 bucket. This upload triggers the Lambda function. The file is copied to the destination bucket, and an SNS email notification is sent. Receiving the email confirms that the stack is created correctly and the application is working as expected. Next, we can redeploy with some changes. Now let's improve our application by enhancing the SNS notification message. The reason for this change is to include more useful details like file name, source bucket, destination bucket, timestamp in UTC, and status indicator. This improves traceability and operational visibility. The only file we modify is src/app.py. We replace the existing SNS message with a formatted message that includes a timestamp using datetime.uckno. No infrastructure or permission changes are required. After updating the code, we redeploy the application. First, build the application again. Then deploy the updated code. Finally, verify the changes. Upload another file to the source S3 bucket. You should now receive an SNS email with the updated message format, including file details, bucket names, timestamp, and status. And that brings us to the end of this tutorial. In this session, we learned what AWS SAM is, why it's useful for managing Lambda functions, how to build, deploy, and redeploy a serverless application, and how to manage updates easily using SAM CLI. AWS SAM makes serverless development faster, cleaner, and more manageable. Thanks for watching, and see you in the next tutorial.